Welcome to our 9th discussion. In today's discussion, we'll be focusing on section 2.6 on infinite limits. And in this video, we'll do some practice problems involving our shortcut for infinite limits. Recall that for limits of the form limit as x approaches either positive or negative infinity, where we have some numerator over some denominator, where the numerator, I'm just going to abbreviate it, the num, and I'll abbreviate denominator, denom, where the numerator and denominator consist of powers of x. The highest power will dominate the growth. The highest power dominates, so we can ignore the lower power terms. The lower power terms. All right, so let's look at some practice problems. So I want to have you try problem number 7, not just 7D, but also 7B and D from worksheet 4. All right, so first I want to give you 4 minutes to try these questions. Pause the video in 4, 3, 2, 1. Pause it and try these for 4 minutes. All right, so hopefully you did that. Hopefully you paused it and tried these for about 4 minutes. For part B, we have the limit as x approaches infinity. And let's expand the numerator to get x squared minus x minus 6 over x squared minus 4. We actually did this problem in the last discussion video, but we did it without the shortcut. And that involved factoring the highest power of x on the top and not factoring the highest power of x on the bottom as well. Okay, in this case, we're going to focus in on those highest powers of x on the top, which is x squared, and on the bottom, which is also x squared. And the shortcut says, well, just keep those and ignore all the lower power terms. So this will be equal to the limit as x goes to infinity of, and I just keep the x squared on the top and just keep that x squared on the bottom. And these will cancel and just give me 1. And that's my answer. We got the same thing without the shortcut in the previous discussion video. All right, let's look at part D. So in D, we need this limit as x approaches infinity of this function. And with this function, we have these terms that are being raised to a power, and then on the numerator, there are 2 sort of power terms being multiplied together. So I'm going to keep the highest power terms within each parentheses. In the first parentheses is the x, and the next parentheses is the 2x squared. On the bottom, it's going to be this 4x to the 19. So if I do that, I'll have x to the 13 first on top, and then 2x squared cubed all over on the denominator, 4x to the 19. All right, so this is the limit as x approaches infinity. And we have x to the 13. With the 2x squared being cubed, I'm going to use exponent properties. When I'm multiplying 2 terms like the 2 and the x squared, and that whole thing is being raised to a power, I do get to distribute that power to both of these terms, which will give me 2 cubed times x squared cubed. Let's see, x squared cubed. If I have a power to a power like this, I multiply the powers, and I'll get x to the 6th power. Okay, so that I'll have x to the 6th over 4x to the 19. And now x to the 13 times x to the 6th, that is perfectly x to the 19. So these will cancel exactly. And what we're left with is 2 cubed, which is 8, over 4. And that simplifies to 2. And that is our answer.